welcome back. Well, we're on the home stretch now in this complete course, and today we're going to begin learning about one of the coolest and most powerful solving techniques of all. And I'm talking about continuous loops. A continuous loop, just like its name implies, is an AIC that circles back to where it started and connects to itself. And it does this in such a perfect way that once it is constructed, you cannot really tell where the beginning or the end is. The logic just goes round and round. It is continuous. But please be aware that even though we use the term loop and say that it circles back to the beginning, it will rarely resemble a real circle. It can snake all around the puzzle, following various paths, and it can take on any number of amorphous shapes. And just like with any AIC, the path can even cross over itself. Unlike an open-ended AIC Type 1 or Type 2, which both have an odd number of links, a continuous loop will always have an even number of links. Don't forget that. There must be an equal number of alternating strong links and weak links in order for the loop to be perfect. For instance, there could be 3 strong links and 3 weak links, or there could be 4 strong links and 4 weak links, etc. And of course, this will always result in an even number of total links. Open-ended AICs Type 1 and 2 always have to begin and end with a strong link, so they will always have an odd number of links. But because a continuous loop has no real beginning and no real end, and because it goes round and round, there cannot be any deviations in the perfect strong, weak sequence. To repeat, just remember that in order for the loop to be truly continuous, it must have an even number of links. This is very, very important. The greatest thing about a continuous loop is that once it is connected, all the weak links become strong links. And this phenomenon can produce huge numbers of candidate eliminations at once, as you will see. In this tutorial, we will look at the shortest and simplest types of continuous loops and learn why the weak links become strong links. And then in the next lesson, we will look at longer continuous loops and go through numerous examples. But before we go any further today, I just want to quickly say that you definitely need to have a solid grasp and complete understanding of strong links, weak links, and AICs Type 1 and Type 2, or what I am about to explain is just going to go right over your head and won't make any sense. So if you are not absolutely confident in your knowledge of those 4 things, or if you do not know how to identify and construct an alternate inference chain, for your own sake, I urge you to please go back and watch tutorials number 3 and number 4, as well as tutorials number 33 through number 37 that explain all these important concepts before continuing here, okay? And for those of you who have been watching all these tutorials in strict numerical order, as I always recommend that you do, you will already have seen tutorial number 27 on X-chains, where at the end I give a 15-minute introductory lesson on continuous loops using X-chains as the model. And then in the next video, which is tutorial number 28 on XY chains, I talk about continuous loops again for about 5 minutes at the beginning, and then for about another 5 minutes at the end, using XY chains as the model. So if you have seen both of those tutorials and hopefully remember them, you will have a big head start on what we will be learning in today's lesson. All right, that said, let's get started. The absolute shortest possible continuous loop will be of 4 links, i.e. 2 strong links and 2 weak links, alternating strong, weak. It cannot be any shorter than that. And the simplest, and by far the most common type of 4-link continuous loop is an Xwing. An Xwing can be thought of as a fish pattern like we learned about in tutorial number 10, or it can be thought of as a continuous loop. It makes no difference which way you look at it because either way you will get the exact same result. When we think of an Xwing as a fish pattern, we think in terms of base sets and cover sets. But when we think of it as a continuous loop, we only need to think in terms of strong links and weak links. Here in this diagram, we have an Xwing on candidate 1. So let's highlight the ones. And as you can see, the base sets are rows 3 and 7, and the cover sets are columns 1 and 5. The two base sets are conjugate pairs that line up in exactly 2 rows and 2 columns, forming a rectangle. And because of this configuration, we know that all the other candidate ones in the cover sets that lie outside the 4 Xwing cells must be false and can be eliminated. So all these candidate ones are false. Let's color them red, like this. And there's your Xwing. One of the 2 candidate ones in each of the base sets, i.e. rows 3 and 7, must be true, which means that one of those 2 diagonal pairs of ones must be true and the other diagonal pair must be false, even though we don't yet know which is which. But it doesn't matter which set is true. We still know that all of those red colored ones must be false, okay? All right, now let's forget the fish pattern and the Xwing, and let's just look at the way the links between those same 4 candidate ones interact with each other. Now you could start on any one of those candidate ones, but let's start up here in row 3, column 1, and we have strong, weak, strong. Just like a regular AIC. But now, because this last candidate one is in the same house with the first candidate one, we can make a weak link right back to the beginning, and boom, we have a continuous loop. We have an even number of links, 1, 2, 3, 4, and they alternate perfectly, strong, weak, and they circle right back to where they started and connect to the beginning. These are the precise characteristics of a continuous loop, even though it doesn't always have to be in this circular or rectangular shape. So let's think about the implications of this. Let's go back and stop short of making that last weak link and just leave it as a 3-link AIC, like a turbofish, a 2-string kite, or a skyscraper. Again, we have strong, weak, strong. Now, because of the implications of this 3-link X chain, we know that one of the 2 endpoints must be true, right? So if this candidate up here were false, then this candidate down here would have to be true, and vice versa. And this ensures that one of those 2 endpoints must be true, and so we can eliminate any other candidate one that can see both of those endpoints. And because they lie in the same house, this means that we can eliminate all the other candidate ones in that house, here being column 1. So these 3 ones would have to be false because they can see both of the endpoints. All right, so now let's start on a different candidate. Let's start on this candidate one down here in row 7, column 5, and we have strong, weak, strong. And again, we have a 3-link AIC, which means one of these 2 endpoints has to be true. Which further means we can eliminate these 2 candidate ones because they lie in the same house and can see both of the 2 endpoints. So now we have proven that by looking at this as 2 separate AICs, we can eliminate those same 5 candidate ones in columns 1 and 5 as we did with the Xwing. But if you can instead envision this as a continuous loop, it will save you the trouble of constructing 2 chains one at a time, and again you will get the exact same candidate eliminations. But the most important point here is to notice that because one of these 2 candidates must be true, we can say that if either one of them is false, then the other one must be true. And if you recall, this is the definition of a strong link. If A is false, then B is true. So this means there is actually a strong link between those 2 circled candidate ones, and likewise, there is a strong link between these 2 candidate ones. And this means that both of those links that started out as weak links have now become strong links by virtue of the loop. This is powerful stuff. And as you will see, This will be the case for all continuous loops, no matter how long they are and no matter how many different candidates they may contain. Once the loop is correctly constructed and connected, all the weak links will actually become strong links, which can many times produce lots and lots of candidate eliminations. Now, of course, with an Xwing, it is much easier to just identify it as an Xwing. I'm just using this as a simple demonstration of the basic logic behind any continuous loop, okay? And remember, with an AIC type 1 or 2, we always have to begin with a strong link. But if you can construct a continuous loop, you can actually begin with a weak link. It really makes no difference which candidate you think of as your starting point or which direction you move, as long as you have an even number of links and they alternate strong, weak, etc., and they perfectly connect back to where you started with no deviations. Now please don't write to me and tell me that I missed a 2-string kite on candidate 3 in this diagram. I didn't miss it. We're talking about Xwings and continuous loops right now, and everything else is irrelevant, okay? I can't tell you how many times I'll do a video on a particular solving technique and someone will write to me and say that I missed something that has nothing to do with what I'm talking about. Please realize that when I show examples in these tutorials, we are not trying to solve these puzzles. I am only demonstrating a particular concept, one random example at a time. And anything else that might be going on all around it is beside the point. When we are actually solving puzzles, like in the random tips videos and in the pencil and paper lessons, that's different. But here in these tutorials, please try to focus on the particular point I am trying to make and disregard everything else, okay? Great. All right, let's move on. Now let's look at a slightly longer continuous loop, but still using only one candidate. This is sometimes called an XCycle, which simply means a continuous loop where every node is the same digit candidate. Here on candidate 8, let's highlight the 8s. We have strong, weak, strong, weak, strong, weak. 6 candidates and 6 links. They alternate perfectly with no deviations and they loop right back to where they start. Now, if we remove any one of those 3 weak links, i.e. the green colored arrows, we will be left with an open-ended AIC type 1 where the 2 endpoints lie in the same house. And because we know that one of those 2 endpoints must be true, we can eliminate any other same-digit candidate that can see both of the endpoints, right? So just like we saw in the earlier example with the Xwing, because this loop is indeed continuous, all 3 of those weak links have now become strong links. So that means that the 2 candidates of each original weak link are now effectively a conjugate pair, which further means that we can eliminate any other same-digit candidate, here being 8, that can see both a blue 8 and a yellow 8 anywhere in the loop. So down here in block 7, this green weak link has now become a strong link, which means either that yellow 8 is true or the blue 8 is true, so we can eliminate this 8. That must be false. And likewise, in block 9, we have a weak link between these 2 8s in that block, so that means this 8 has to be false, because either the blue 8 is true or the yellow 8 is true. And then up here in row 3, we have a weak link between these 2 8s, and so any other 8 in that house, that row, can be eliminated as false, and there are 2 of them. There's one here, and there's one here. Got it? All right, now let's take a look at a continuous loop that uses different digit candidates. Here in this diagram, we have strong, weak, strong, weak, strong, and weak. Again, 6 candidates and 6 links. They alternate strong and weak with no deviations, and they loop right back to where they start. But this time it looks a little different because one of the weak links is within a single cell instead of a house. But the logic is the same. All 3 of those weak links have become strong links because the loop is continuous. If you removed any one of those 3 green-colored weak links, you would again have an open-ended AIC proving that one of the 2 endpoints must be true. Now here in this cell in row 4, column 5, if we remove that weak link between the 1 and the 3, we get an AIC with those 2 candidates as the endpoints. So that means either the 1 or the 3 must be true, which further means we can eliminate this 5 and this 8 from that cell, because either the blue 1 or the yellow 3 must be true. Is that cool or what? Now remember, an AIC type 1 has to end with same digit candidates, and a type 2 has to end with different digit candidates that lie in 2 different cells. So this is technically neither a type 1 nor a type 2, but still it is an AIC that starts and ends with a strong link, which means one of those 2 endpoints must be true. And with the other 2 weak links, because they are between same-digit candidates, we can eliminate any other same-digit candidates in the houses where they lie. Now there is a weak link between these 2 ones here in row 6, so that means this one over here must be false because it lies in the same row. Either the yellow one or the blue one must be true. And likewise, there is a weak link between these 2 3s in block 6, so one of them must be true, which means we can eliminate these 2 candidate 3s as being false, because that weak link has turned into a strong link by virtue of the loop. So as you can see with this very short continuous loop, we were able to get 5 candidate eliminations. All right, now just for fun, let's quickly use the propagation rules that we learned about in the last video, tutorial number 38, to check the validity of this loop and verify that we have put it together correctly. If you recall, when we are using the propagation rules, we only need to be concerned with the links that are entering and leaving each cell. Any links within cells are just the natural result of alternating strong and weak links. So let's redraw this same loop, but this time we will only look at the links entering and leaving each cell, okay? So we had a strong link between these 2 1s, and then we had a weak link between these 2 1s, and then we're not going to draw this strong link between the 1 and the 3, and we had a weak link between these 2 3s, and then we had a strong link between these 2 3s. So we're only concerned with those 4 cells and those 4 links. So rule number 1 says if you have a cell with 2 strong links, they must be connected to 2 different digit candidates, and the cell can be by value or not. And that's the case for this cell in row 4, column 5. We have a strong link coming out and a strong link going in, and they are connected to 2 different digit candidates, and whether there are any other candidates in that cell doesn't matter. And then rule number 2 says if a cell has 2 weak links, they must be connected to 2 different digit candidates, but this time it must be a by-value cell. And as you can see, that's the case for row 6, column 8. We have a weak link coming in and a weak link going out, and they are connected to 2 different digit candidates, and that is a by-value cell. And the reason for that is because the link between those 2 candidates has to be strong, so it can go weak, strong, weak. So that is correct. And then rule number 3 says if a cell has a weak link and a strong link, they must both be connected to the same candidate. And as you can see, that applies to the other 2 cells in the loop. Down here in row 6, column 5, we have a strong link coming in and a weak link going out, and they are both connected to that 1. And up here in row 4, column 7, we have a strong link going out and a weak link coming in, and they are both connected to that blue 3. So this simply shows that our loop was correct in the first place. Whether you use the propagation rules or whether you just alternate strong and weak links is entirely up to you. But if you want to be 110% sure your chain or loop is correctly constructed and valid, you can always use some combination of both. All right, let's go to the next diagram. Here we have an AIC type 1 beginning and ending with candidate 7. With an open-ended AIC, if either one of the endpoints is false, then we know that the other must be true because of the implications of the chain. This means that at least one of the endpoints must be true. So there is what I call an effective strong link between those endpoints. You can say with certainty, if A is false, then B is true, even though those two endpoints do not see each other. It is an effective strong link. So because we know that one of these two endpoint 7s must be true, we can eliminate any other 7 that can see both of those endpoints. And in this diagram, there are 2. There is one here, and there is one here. Those 2 red 7s are false. But as I have shown many times in previous videos, this does not preclude the possibility of both endpoints being true, and many times it is the case that both endpoints are true. This is not necessarily so, but it does happen more often than you might think. And coincidentally, if you went ahead and finished solving this puzzle, you would find out that indeed both of these endpoint 7s are actually true. But with a continuous loop, where we have all these separate AICs that we can visualize by eliminating the weak links one by one, it is not possible for both of those two endpoints to be true. Why? Because if the endpoints are same digit candidates, they will always be in the same house. And if they are different digit candidates, they will always be in the same cell. This means that it is not just an effective strong link between them like it is with an open-ended AIC, it is a real strong link. Because they can see each other, one of them must be true and the other one must be false. They cannot both be true. It is impossible for both of them to be true. And they cannot both be false because of the implications of the chain. This further proves that in every consecutive pair of candidates in a continuous loop, no matter which direction you are going, one must be true and the other must be false, even though we don't yet know which is which. This is a very important sentence, so please allow me to repeat it. In every consecutive pair of candidates in a continuous loop, no matter which direction you are going, one must be true and the other must be false, even though we don't yet know which is which. Once you connect a continuous loop and are certain it is valid and follows all the rules, the circuit is closed. So if you alternate the colors on all the candidates like we have done here, blue, yellow, etc., you will immediately know that either all the blue ones are true and all the yellow ones are false, or vice versa. All the yellow ones are true and all the blue ones are false, even though we don't yet know which color group is true. And of course, you could use any two colors you want. I always use blue and yellow because they are easy for me to see. That's the only reason. But what this means is that you can eliminate any same digit candidate from a house where there is a blue one and a yellow one, and you can also eliminate any different digit candidate from a cell where there is a blue one and a yellow one. And this is just another way of saying that all the original weak links in the loop have now essentially become strong links. And we are going to call this a converted strong link to imply that it began as a weak link, but now that the loop is constructed and connected, it has been converted into a strong link. As I mentioned earlier, an Xwing is the simplest form of a continuous loop. It is an XCycle of exactly 4 links. For instance, here is an Xwing on candidate 7. The base sets are row 1 and row 5, and the cover sets are column 3 and column 7. And so in terms of a continuous loop, we have strong, weak, strong, weak, right? But you could also have an XCycle with 4 links that is not an Xwing. Like if we had something that looked like this, we would again have strong, weak, strong, weak. And you could eliminate all those red colored 6s in the same 2 houses with the converted strong links. Or it could look like this, with the strong links in the columns and the weak links in the blocks. And again, you could eliminate those 6 red-colored 6s. But of course, this could only happen in a single chute like you see here. If the 4 candidates were situated in more than one chute, the only way you could have an XCycle of 4 links would be in the shape of a rectangle or a perfect square, and then it would obviously be a normal Xwing. Otherwise, you could not connect the 4 candidates. And if you have a swordfish where there are only 2 candidates in each base set, like you see here in columns 3, 6, and 9, this can also be seen as an XCycle of 6 links. And thus, the 3 weak links become converted strong links, giving you the exact same eliminations as the swordfish itself. The strong links are the base sets, and the converted strong links lie in the cover sets, which are rows 2, 3, and 9. But of course, this will not work if there are 3 candidates in any one of the base sets, and in that case, you could only view it as a swordfish. But please be aware that it is going to be a rare occurrence when you find an XCycle of more than 6 links. Continuous loops of more than 6 or 8 links are most likely going to be composed of several different digit candidates, so they will probably not be XCycles, and that's fine. So when we have an AIC with freestanding endpoints that cannot be connected, we can only make useful deductions about the 2 endpoints. We don't know anything for sure about all the candidates in between. The true-false value for each candidate in the chain will switch depending upon which end you imagine as the start of the chain, and we don't know for sure which of those 2 ways it really is. But as soon as your chain has 2 same-digit endpoints that land in the same house, or 2 different digit endpoints that land in the same cell, then the whole ballgame changes. When this happens, you can make a weak link between those 2 endpoints, which forms a continuous loop. And because the chain is now a loop, we can make useful deductions about all the candidates in the whole loop. This is fantastic. The only downside of a continuous loop is that they are somewhat of a rare occurrence. So probably the best time to look for them is when you are about 2/3 of the way through the puzzle and you happen to see lots of conjugate pairs and bi-value cells, which as we know indicates a high probability of finding any kind of AIC or loop. Okay, before we wrap up today, let's go over some bullet points as a review. In a continuous loop, there will always be an equal number of strong links and weak links, which will always result in an even number of total links. If you remove the weak links one at a time, you will see that it is simply an interlaced series of AICs in which both the endpoints are strongly linked. The links between cells, i.e. from one cell to another cell, are always going to be between same-digit candidates, and the links between different digit candidates can only be within cells. In an open-ended AIC where the 2 endpoints do not see each other, you can only make deductions about the 2 endpoints. But once the loop is connected and continuous, everything changes, and we will know something about all the candidates. By using blue and yellow to alternately color the candidates, you will know that either all the blue ones will be true and all the yellow ones will be false, or vice versa. Any same-digit candidate that lies within a house containing both a blue one and a yellow one must be false. And if there is a blue and a yellow candidate within a cell, all the other candidates in that cell must be false. When you start out, the strong links are already strong. I know this sounds silly, but what I mean is that there won't be any additional eliminations as a result of the original strong links. Otherwise, they wouldn't have been strong links in the first place. But after the loop is connected, the 2 candidates in every original weak link effectively become a conjugate pair, i.e. a converted strong link, by virtue of the implications of the loop. You can start on any candidate and go in either direction. The loop will be valid in either direction. And you can start with a strong link or a weak link, as long as you alternate the links and they return to the beginning with no deviations. Just remember that you cannot construct a chain without strong links, which can only be in the form of conjugate pairs and bi-value cells. So conjugate pairs and bi-value cells are the superstars of your chain or your loop. Whenever you find a continuous loop of any length, you can really celebrate because it will be your lucky day. Okay, that's going to do it for today. Thanks for watching. If you enjoyed this video or found it helpful, please click the thumbs up icon and the red subscribe button, and be sure to click the little bell icon if you would like to be notified of new video uploads. In the next video, tutorial number 40, we're going to focus on longer continuous loops. I'll give you some handy tips for constructing them, and we'll go through lots and lots of examples, okay? So I hope you will join me for that very important lesson. Until then, be well and be happy.